The following video tutorial will help you to understand your data and show you how to conduct exploratory analysis for this data. The data we will be using for these tutorials is the Craven's dataset, which is available on the Learn page. For each region we measure 10 variables. These are sales, the total sales in units for the region; time, the time in months that the sales representative for the region has been employed by the company; potential, measure of market potential for the region; advertising, how much money was spent on advertising in the region; share, the average market share in the region for the last 4 years; change, the change in market share in the region over the last 4 years; accounts, the total number of accounts in the region; work, the workload for the region; rating, the performance indicator for the sales representative in the region; and area, the socioeconomic status of the region on a scale from poor, coded as 1, to rich, coded as 4. Our aim is to build a model to see how the variable sales is related to the other variables. First, we need to look at what types of variables these are. Sales is our dependent variable, as we're interested in modelling sales as a function of our other variables. This means that all the other variables are independent or predictor variables. We should also look at whether these variables are categorical, ordinal, or quantitative. All of the variables except area are quantitative, as they have a clear numerical value. There are 4 predictor levels for area, ranging from poor to rich, and so area is an ordinal variable as it has no scale data. That is, we don't know if the difference between levels 1 and 2 is comparable to the difference between levels 3 and 4. Ordinal predictor levels cannot be directly entered into our regression model, so these categorical levels have been coded from 1 to 4 in order for us to carry out our analysis, but they will require special treatment in the model. Now that we have a better understanding of our variables, we can carry out our exploratory analysis. First, let's determine the null and alternative hypothesis for a correlation test on our data. If the correlations are significant, it makes sense to build a model. If they are not significant, then it does not make sense to build a model. Our null hypothesis states that our variables time, potential, advertising, share, change, accounts, work, rating, and area do not relate to sales. Our alternative hypothesis says that these variables do relate to sales. We will now look at how to open our data in R. The Craven's data file can be found on Learn in a .csv file. This data can be read into R using the read.csv command, and we will assign the data to the name Craven as follows. Notice that R uses a / rather than a / to separate subdirectories. However, this depends on whether you are using a PC or a Mac. We can view our data in R by simply typing in Craven. We now need to attach the Craven's data so that we can view the data in each individual column. This can be done using the attach command as follows. Now let us produce a scatter plot for time versus sales. This can be done in R by simply using the plot function. From the graph, we can see that there is an extreme value on the far right of the plot. Extreme values can strongly affect the model that we fit to our data. This is the only data point for x values between 220 and 400. This suggests that if we were to fit our linear model for x values between 0 and 220, we are likely to produce quite a reliable model. However, if we fit our model including this extreme value, then this affects our regression line and our model becomes less reliable. Let us look at Anscombe's quartet. These 4 different sets of data all have the same mean, variance, and correlation, and the same linear regression line can be fitted to all of them. In picture A, fitting the linear regression line of y equals 3 plus 0.5x seems like a reasonable model. However, this linear model is not suitable for picture B. This would fit a quadratic model better because of the shape that the data produces. A linear model is suitable for picture C as the data points form a straight line. However, the outlier changes the linear regression line so that this line does not pass through most of the data points. This shows how an outlier can affect the regression model. Picture D is an example of poor sampling, as the majority of data points offer just one value of x. In order to get a sense of what the relationship is between two variables, you need to sample several values of the independent variable. In this case, we cannot judge what sort of regression model is appropriate because only two values of x have been sampled. Now we will assess the correlations among the variables to test whether multicollinearity exists. Multicollinearity means that there is a correlation among the predictor variables, and this can have a serious effect on the fitted model. We will ignore correlations relating to area because, as mentioned earlier, this does not contain scale data. We can produce a correlation matrix using the following command. This can be easier to interpret if we round the correlation coefficients to 3 decimal places using the following command. Here we can see that the amount of time that the sales representative has been employed for the region and the total number of accounts in the region have a high correlation of 0.758. This suggests that we will need to remove one of these variables before we fit our model. Also, rating and change have a medium correlation of 0.549, so we should keep an eye on these variables too. Now let us produce a scatter plot for accounts versus sales so that we compare this to our time scatter plot. We are now ready to start fitting a model, but this will be shown in the next video. Make sure you save this R script in the same file as your Craven's data file. Let us summarize what we have learnt in this video. We have identified and categorized our variables in terms of dependent or independent, and categorical, ordinal or quantitative. We have transferred our data into R and used R to produce a correlation test and to measure the correlations among predictor variables. We have also used R to produce scatter plots. We are now able to fit a model to our data. The next video, entitled Model Building, will show you how to do so.